So today we'll be looking at our schematics. We'll try to understand the power rail of charging ports, how the voltage requirements, what the voltage requirements within your charging port, how it works, and how you can dictate the voltage, accurate voltage that is meant to flow on your charging port. If you look at it critically from here, we have the charging port. This is our charging port. So, and these are the pins on the charging port: 1, 2, 3, 4, 5, up to 8 pins, and this is ground. The two pin 9 and 10, they are ground, so they are the ground key. So when you look at it from here, the charging port, the power flow from pin 1, it goes from pin 1 of 1 and goes to this. There is a resistor that is in we call it we have okay, this is not a resistor, this is a coil. It flows to the coil. This is a coil, and the coil are in 2 pole. So, and it's kind of grounded to this place, and between the ground is a capacitor that is meant to be there. So we have 2 capacitor on in between the coil. So, and this same voltage travels down towards to this first MOSFET. You can see this is a MOSFET, and under this MOSFET now we tag this to be I think this should be a P-channel MOSFET. This should be a P-channel MOSFET, and the MOSFET has pin 1, 2, 3, 1, 2, 3, and another one here. So, and this is our what? This we have the drain, the gate, and the source. So there's another jumper at the top that crosses down to this another FET. There's another FET here, MOSFET. In between the MOSFET there's a resistor. You can see this is a symbol of a resistor. This is not a coil, this is a coil. If you look at this critically, this one is a coil, this one is a coil. A coil is kind of if you look at it, it's in form of zigzag shape, while a resistor is our standard resistor is in this form, is in sinusoidal form, or just as if a voltage is moving. That's how a resistor is. So but a coil is in form of zigzag shape. So these are 2 coils. This is capacitor, this is ground, and when you look at here, these are what resistors. So this resistor is cascaded to protect this device. This is a MOSFET. So this MOSFET is being protected by this resistor, and the resistor, you can see from pin 1 here, it is taken from pin 1 to 2, and the ground part of the MOSFET is connected to one leg of the pin. So that is the pin 4 is connected to one leg of the resistor. The pin 4 of the MOSFET is connected to pin 2 of the resistor, while from the battery side, the pin 1 of the resistor is connected to this part. So you can see it very well. So, and it is further taken just for protection sake. Another resistor is also here that is protecting it from the ground. It's taking it down here, and the same pin 2 is connected to the part 1 of the leg, which is pin 2 of this MOSFET. There's another MOSFET here, L2N7002DT1, the DW1. It's another MOSFET here. So in this flow now, the pin 1 of this MOSFET is what is cascaded to the ground. So there is no flow. When you are taking your reading, you already know that this is ground, and that is how it flows. So let's proceed. So we have already discovered that from that there is a MOSFET, and it stops at, when you look at it critically, you know that this MOSFET that was here was not just there. This ground is kind of disengaged from the upper MOSFET, and the other pin is cascaded again to another MOSFET. You can see another MOSFET here. This should be 5. This will be the 5th MOSFET. Can you see it here? And it's connected to another resistor. So mind you, the voltage requirement in this MOSFET now that is flowing from this from this place down to across to the resistor is 3 volts. So you have 3 volts. So if 3 volts is not present here, you should know that there is a problem. That is why I told you in my previous videos that whenever you are working on your motherboard, you should be mindful of all the voltage requirements, and at the same time you should make sure that you are using your schematics. If the schematics is quite explanatory and you are able to interpret the schematics, you will know all the voltage requirements that is meant to be on that particular line without having to ignore the voltage. Once the voltage is not reading on that particular line, you should know that there is a problem. Now let's look at this. After these 3 volts, what do we have here? We still have another resistor in this place, which is a 220k resistor, and the tolerance is 5%. The tolerance of this resistor is 5%, meaning that any voltage that exceeds this 220 or any voltage that exceeds this percentage, it cannot take it. What will happen? The resistor will cut or it will melt. There will be a short circuit around this environment, around this circuit. So that is why it's giving the tolerance. Each of these resistors have a tolerance of its own. Like here now, the 4.7k resistor has a tolerance of 5%. And this one also, the 100k, has a tolerance of what? Of 5%. If you look at it, the 100k resistor, it has a tolerance of 5%. So that is how the voltage flows. Now let's proceed. We'll see that as we proceed. Okay, let's look at where this voltage is going. Now after getting down the voltage, we look at it that okay, the voltage is coming. We already have 3 volts. We know that this 3 volts is coming from our I/O controller. So from the I/O controller, we have 3 volts that supplies even up to the charging port. So the 3 volts that is coming down here to this FET is also going to the AC in. So this AC in, meaning that when your power jack or your power cable is coming, your power charger is connected, the AC in will give you what? Will give you 3 volts. 3 volts that will go to this MOSFET. Now, and we also have AC and charger, which will be like AC and charger, which is like greater than 30 or lesser than 30. So that's what we have on the AC in charger. So if we want to modify more on this, we can decide to go and type in our AC in here. We'll type our AC in here to find AC in. We will now discover the voltage that is meant to be on AC in. Do you understand? We'll discover the voltage that is meant to be on the AC in. Now, this schematics is not stopping here, because if we proceed, we will discover that there are more voltages that need to be there. Now we look at each of these protection. We have our diode. Diode is there to protect each of these lines. It is cascaded in such a way that it is in form of a bridge rectifier. It is meant to rectify this circuit to avoid what? Directional flow. It controls the flow of the current so that it will not flow in another way. So that is why we have what? We have a bridge rectifier here. We have another bridge rectifier in this place, rectifying circuit. So that is how you study your schematic. Thank you for watching my videos, and keep watching. Thank you very much.